Okay, so here in this chapter, and just a brief chapter here, I don't want you to think that just because it's a short chapter that it's not something that you need to worry about or be concerned with. It's actually uh, pretty terrifying, honestly, um, for a number of reasons. You might have seen recently, for example, projections are that 50-year floods, so within your lifetime, on the coastal parts of the United States, so New York City, most of Florida, most of Louisiana, Carolinas, um, Georgia, for that matter, um, parts of Texas, Houston, Galveston, stuff like that. Um, those places are going to be experiencing within your lifetime, daily flooding events equivalent to a 50-year flood. And the way that we categorize floods is that once the severity is expected to be kind of cyclic, right? So a 50-year flood is one that is so bad you only expect to see it once every 50 years, right? And by the end of this century, that's going to be a daily thing. So it's pretty terrifying. And it becomes more and more terrifying as we not only don't do anything about it, but we have government in place that seems to want to continue to go the opposite direction. So I'm worried for y'all. I honestly am. It's pretty terrifying. Um, that said, it has limited application. It has application, but limited application to what we can do as managers. So we do need to consider it, but it's not going to be the sort of level of detail that we'll talk about at, say ecology or environmental science or any of those other courses. So again, I'm going to leave this up here just for a second. You can look at it if you want to, but we're going to kind of move forward. When we're talking about climate change, global warming, no way you'll see put out there usually by people who want to make hilarious jokes about, oh, I found a snowball, let's have some global warming, stuff like that. But really the more accurate term here is climate change. And this is a long-term shift in weather patterns. Remember, climate is just long-term weather patterns, right? And so climate change then is changed to climate. So over years and decades, normally we think about climate change, we look at the historical record. Climate change occurs on 1,000-year timescales. Typically, we're now looking at decadal timescales, which again is horrifying. We care about this stuff because climate obviously is built out of weather, and weather is something we talk about a lot. It's the central component, the central abiotic component anyway, of ecosystems. You can't restore a desert if you now live in Miami, for example, right? It's going to be a major component of what's going on. And the reality of it is that we are really having major impacts on this stuff. And sooner rather than later, it's going to affect us, and we're going to be really sorry. At this point, it is what it is. As far as what's causing it, I encourage you to listen to me and to climate scientists rather than millionaires who work for the oil industry, who might have a vested interest in remaining millionaires, for example, as opposed to people like me who just want our kids to grow up in a healthy planet. I don't know, it's an idea. What climate change in terms of the recent climate changes is it's us. Okay. There are external forcing factors, things like solar radiation. It is vastly outweighed by all of these things. Okay. The burning of fossil fuels releases carbon dioxide, releases carbon monoxide, things called halocarbons, nitrous oxide, release of methane, bad stuff. Okay. Slash and burn agriculture, the burning of forests. Now I know, right, we talk about use of burning as a valid management tool, and indeed it is a valid management tool, and it is a normal, natural part of a lot of ecosystems. What I'm talking about here is when we burn down a forest so that we can plant a banana plantation. Okay. It feeds into agricultural practices here, of course, but what I'm thinking about here is things like growing raising cattle, cattle ranching, cattle farming. It's not an easy issue to get around, but it is a pretty destructive practice. And I say this as a person who really likes to eat beef. And I say this as a person who has family that have been, they're no longer in it, but were cattle farmers. It's bad. It's bad for us. It just is what it is. So what's actually happening here in terms of changes to climate? It's not uniform around the planet. Different areas are changing in different ways. We're seeing places warm up. We're seeing places get colder, believe it or not. We're seeing, while global average temperature is rising, certain places are getting colder, some places are getting hotter. Some places we're seeing greater seasonality. So the difference between summer and winter, rainy season and dry season are getting more distinct. Some places we're seeing less changes in seasonality. And this is simply because the way that air and water vapor move around the planet is not uniform, right? Weather is driven by circulation of air and circulation of the oceans. And those things are not symmetrical, right? Another thing that we're seeing here, obviously, average temperatures are rising. Okay, doesn't mean we don't have winter anymore, right? But it means average temperatures are rising. Sea level is rising. Melting snow and ice. Obviously, the glaciers are melting. You can see this for yourself. I don't want to rehash it, mostly because I don't want to get depressed. Extreme weather events are becoming more and more common. You can see this for yourself. It's not a conspiracy. It's the weather now, right? Things are getting weird. And it tends to be greater here than it is in the southern hemisphere for a couple of reasons. There's more land in the northern hemisphere than in the southern hemisphere. Southern hemisphere just really has South America, sub-Saharan Africa, and Oceania, so Australia, New Zealand. Doesn't really have much. Here we've got all of Asia, all of Europe, all of North America, Central America, northern part of Africa. There's a lot more land mass up here, which is driving a lot of the changes in weather here. What are the things we might expect to find? Obviously, there are going to be some evolutionary consequences, right? Things are going extinct faster than they can adapt. That's just the reality of it. And those are going to be longer term, decadal, century, millennial consequences. Over the shorter term, what we might call phenological consequences, things that we can observe changing right now. Changes to migration patterns, okay? Changes in timing of things, in particular, as seasons change, as things might get warmer earlier or later, as the difference between summer and winter might get less pronounced or more pronounced. Those temperature changes are the cues that lead to a lot of breeding patterns, okay? And they're also the cues that lead to changes in, say, hibernation process, okay? All of which gives us, well, we come back to this idea of this trophic mismatch hypothesis. And I think we've talked about this before. And this kind of goes back to something we talked about in the last unit of the course, right? We talked about how breeding and calving, things like that, usually are tied to, say, green up, right? You want your offspring to emerge right at the time that the food that they're going to eat is most available to them so they can be successful, right? Well, the trophic mismatch hypothesis, what this basically says is that the cues that animals and plants are using to emerge in the spring, shall we say, are not necessarily the same. And so while our baby caribou might be calving or might be being calved at one time of the year when green up usually happens, green up might have happened a month ago, or it might happen a month from now, right? They're no longer on the same schedule. And the result of that is that there's no food for those calves, and those calves die, right? And if there's no calves, there's no next generation. There's no next generation, there's no caribou, right? And this comes about, and we're observing this right now happening, coming about as a result of some of these shorter term changes in weather and climate. Other things we might see or are already seeing in terms of distributional responses, right? So where do we find plants and animals? We're seeing latitudinal and elevational shifts. So if we think about just the northern hemisphere, right? As you go closer to the equator, it tends to get warmer. As you go farther from the equator, it tends to get colder, right? As average temperatures rise, okay, it's warmer farther and farther and farther away from the equator. So species that were living, say, in Florida, Alabama, Georgia, okay, in the south, they're now finding it okay, right? The weather is now okay, the climate is now okay for them to live, say, in Kentucky, right, or Tennessee, or the Carolinas, or Virginia even. And so they move north, right? They shift north in terms of their latitudinal range. And the species that used to live in Kentucky and Tennessee and the Virginias and say the Carolinas are now shifting north too. They don't live there anymore. Now they live in Pennsylvania. They live in New York. They live in Ohio. Okay, they live in New Jersey. Species that live there get shifted north. And that's fine, right? As long as you can continue to shift north. But what if you're already kind of at the top? You're getting squished, right? You're getting pushed down. You're no longer, there's nowhere for you to go. And so where you go is extinct, okay? We also see this in terms of elevation, right? You go farther up a mountain, the colder it gets, right? You can test this for yourself. Go on the Weather Channel right now, look up the temperature in Crescent, look at the temperature in Hollidaysburg. That's only half a mile, right? And it's probably 6 degrees right now, okay? So again, the same thing, right? Certain species can't live at certain heights because it's too cold, but now it's getting warmer, and so they can move up. And as you move up a mountain, there's less and less and less area, right? So again, we squeeze some species out. Things go extinct. Okay, so it's a big problem. It's really a big problem here. Again, we think about this in the northern hemisphere more than the southern hemisphere, simply because there's less land mass down there. Okay, more land mass up here, bigger climate change effects, less land mass in the southern hemisphere, less of that. We're seeing, because of the changes in where species are found, we're seeing new interactions, right? As habitats change, we're seeing new interactions, right? Right now, right, we're seeing, and obviously the current pandemic is not an example of this, but we're seeing lots and lots of other pandemics, things that could have been really bad and have thankfully been headed off. They're changed because new viruses are emerging, right? Because new habitats are being sort of exploited and things like that. So lots and lots of different dynamics here that can have not just effects on you and me and the wildlife around us, but also, of course, on human health. So how do we solve this? Well, it's too late to solve it. Now we're really just trying to make it not as bad. And the way that we need to figure out about how to make it not as bad is we need to understand what we expect to happen. Because so we do things like bioclimatic envelope modeling. Whenever you see climate models, right, the farther away from today they get, there's usually like a single line, or maybe a couple of single solid lines that run through it, and then kind of this cone of uncertainty around it. And the farther you get from now, the bigger that cone gets. That doesn't mean that the models are wrong, okay? That simply means that the farther out in the future it gets harder to predict. This is the same with the weather, right? You don't see people protesting the local weatherman because his prediction for the weather in a week was wrong, right? Well, he doesn't know what he's talking about. It's just that it's hard to predict in the future, right? And so that's what this envelope is all about, right? Trying to say these are the potential, this is the range of possibilities, right? And using these ranges of possibilities, and within those we have more and less likely possibilities, we can generate what are called habitat suitability models. Say, okay, as this changes, what is this habitat going to look like? What is this habitat going to look like in 10 years, 20 years, 30 years, whatever? We can also do vulnerability assessments, right, for species. How sensitive are they going to be to climatic change? right? Do they rely extremely heavily on one plant or animal species that may or may not be there? Okay. What is their capacity for resilience? Are they likely to shift to a new resource in the absence of one or the other? What's their adaptive capacity? And how exposed are they to the effects of climate change, right? Is their habitat likely to change a lot? Is their habitat likely to change a little? And again, even just think about northern, southern hemisphere, right? Exposure is greater here in the northern hemisphere than it is in the southern. So where does this some kind of come to you? You know, it's one of those problems that is so shockingly massive, and that people tend to feel so incredibly small, particularly people that have been trying to get changes to happen and no one seems to listen or care. It can be really discouraging, and you can find yourself stuck in this period of inaction where you're not going to do anything. Yeah, I can't change anything. I'm not going to do anything. Why bother? Right. The reality is that's the most single dangerous thing you can do is to do nothing. Right. You know, if you are ever trapped in a dangerous situation, and climate change most certainly is a dangerous situation, you have to do something. You can't do nothing. Doing nothing is the way to die. So we need to find a way to kind of get over that hump a little bit. Small actions sometimes, right? And so you as a wildlife manager, you're the definition of small actions, right? You're working on your couple of hectares, right? You might be working on a whole forest even, but it's small actions, right? And planning and trying to incorporate the things that you know are coming and not burying your head in the sand is important, not only for the landscape that you're managing, but also it provides us data, right? Saying, knowing what's happening gives us kind of a trajectory, gives us kind of a set of information that we can say, point to say, this is what is happening right now, right? As opposed to this is what we think is happening right now. So honestly, you know, you guys on the front lines would be really incredibly important to this whole thing, to try to mitigate, to try to level off, to try to flatten this curve too, right? But somebody's got to do something. And a big part of that is that you can't be by yourself. You know, we're trying to be by ourselves right now as a nation. Climate change doesn't stop at the border, right? It doesn't stop getting warm at Windsor, right? And Detroit is going to remain normal, right? It's everywhere. And so you're going to have to reach out. You're going to have to work with other members of your agency. You're going to have to work with other agencies. You're going to have to work with other nation states even to try to do something about it. Because make no mistake, we have to do something. We cannot continue to do nothing. We cannot continue to make things worse. We have to do something. Okay, so I realize that's not the most lighthearted way to go out on a video here, but sometimes some sober thought and reflection is what's most needed.